Hello and welcome to the first of 3 videos in how to use KeHaTools in marketing research and statistics. And here's the agenda over the examples we're going to go through and some more examples. So let's look at the first example. We have some observations. Are these normally distributed? Let's go over to Excel. Here I have the data typed in. In order to see whether we have a normal distribution, we need to start KeHaTools like this. Go into descriptive statistics and construct a normal fractal diagram. I mark my data points and I get the following diagram, and I can clearly see that these data points are distributed quite close to the straight line, so we have a normal distribution. In the next example, we have a telephone company who wants to enter the market on Bornholm, a small Danish island. They only enter the market if the market has a certain size. They don't know this size, but they have made a market survey. They ask 100 households what their communications expenditure would be, and they got an average of 5,000 Danish crowns and a standard deviation of 700 Danish crowns. If we just calculate, we see that the market should have a size of 275 million Danish crowns, and the telecommunication company's share would be 27.5 million crowns. But that is probably not correct. We need to take the sampling uncertainty into account. So we make a confidence interval. We go to KeHaTools, a confidence interval for a mean. We have summary data. The sample size was 100 customers. The average was 5,000. The standard deviation was 700. And we know the population size, 55,000. And we use normally a confidence level of 95%. And since we have a large sample, we can use the C confidence interval like this. So the true average is between these two numbers. In order to get the market size, we multiply the lower bound with the population size, and in order to get the upper bound for the market size, we multiply the upper bound for the average with the population size. Is around 10% of these numbers, so this times 10%, and the same down here. So the company should expect a share between 26.7 and 28.2 million crowns. In the next example, we are going to hold a referendum here in Denmark in a month's time, but we have made an opinion poll. And we want to know, we know that 55 out of 100 are going to vote yes, but how precise is this estimate? We can use KeHaTools again. Confidence interval for the proportion. Our sample size is 100 persons. We have 55 who want to vote yes. We don't know the population size. Level of confidence 95% as usual, and we almost always use an approximate confidence interval. So get this result. We can change these numbers to percent if we want to, like this. And also this one. So our sample says that around 55% are going to vote yes, but that is rather uncertain. We can only say that we are certain that the true proportion of yes voters would be between 45.2 and 64.8%. In the next example, we want to make a new opinion poll, but we want a margin of error that is much smaller than these 9-10%. We want a margin of error of only 3%. How large a sample do we need for that? We use KeHaTools and select the button sample size for a proportion. We know that around 55% wants to vote yes. We want an error of margin of 3%. We don't know the population size. And we get the following results. We need to ask 1057 persons. If we didn't know that around 55% wanted to vote yes, we could make the same calculation. But when we don't know the proportion up here, we need to take the worst case into account. That would be 50%. Error of margin 3%. And we get 1068. So if we know more than just the uninformed 50%, then we can get around with a slightly smaller sample. In the next example, we have the same case, but now we know that the share, the estimated proportion, is only around 2.5%. First, we need to make a confidence interval for proportion. 200 voters, 5 want to vote on the small party. And if we change all these numbers to percentages, we see that the party is going to get between 0.3 and 4.7% of the votes. And as the party needs at least 2% in order to get representation in parliament, we are not sure that this party is going to be elected. Again, we need to figure out a sample size so we can decide this issue. So we go back to KeHaTools, confidence interval, sample size for proportion. The estimated proportion is around 2.5%, but we need a rather small margin of error, 0.5%, and we need a rather large sample size of 3,746 persons. In the next example, we have a large party who had an opinion poll 1 year ago with these results, and now we have made a new opinion poll, and the party has apparently a larger support than before. But is this correct? Now we calculate a confidence interval, but the confidence interval is a difference between two proportions. The proportion now, so we write in the current sample, and the proportion a year ago, and we now calculate the difference between these two proportions. We get the following results, and we see that the difference is apparently positive, but it could be negative, so we can't conclude that the party has an increase in share voters. In this example, we have a bank that receives telephone calls, and we want to calculate a confidence interval for the average length. We have a sample, a small sample of only 20 calls with this information. We know that by constructing a normal fractal diagram that we have a normal distribution. So let's calculate a confidence interval for the mean. We still have summary data. 20 observations, average of 7.53, a standard deviation of 3.27. We don't know the population size. And since we have a small sample that is normally distributed, we're going to use the T confidence interval. And we get this result by rounding off to a smaller number of digits. We get the following. Now we have a government bond, and we have a sample of the daily yields. This is a large sample, so we can use a C confidence interval, and in that case we don't care whether the observations are normally distributed or not. Let's make a confidence interval for this mean. The average is 0.087, a standard deviation of 0.022. And now we need a 90% confidence interval. And as the sample starts, we're going to keep the C confidence interval, and we get the following results. Next, we need to figure out how large a sample size is needed. We have a 95% confidence interval, and we have an idea that the margin of error should be 2,500 Danish crowns, and the standard deviation is around 50,000 Danish crowns. So we go into sample size, type in the standard deviation, the error of margin, and the level of confidence, and we need a sample size of 139 persons. In the next example, we are going to compare the mean of two different customer groups, A and B, and we know the following information. We have two samples. Group A, 50 persons with a given sample average and standard deviation. Group B, 50 persons also, and these means and standard deviations, and we know that they are normally distributed. So we calculate a confidence interval for the difference. Sample A, 22355, 645, 50, 21430, 780, and as we have large samples, we can simply just use the C confidence interval, and we get this result. We have a chain of shops around northern Jutland, and they have made an advertisement campaign. Here are the shops, the titles of the shops. Here are the weekly sales before the campaign and after the campaign. And what we want to know is whether the campaign has had an effect. So we can calculate a confidence interval for these differences over here. First, as we have a small sample of around 10 shops, we need to make a normal fractal diagram to see whether these differences are normally distributed. and this looks nice. We have a normal distribution. Now we need to find a confidence interval for the mean after minus before this difference, and we now have paired observations, so we're going to use this button. And now we have the observations, we don't have summary data. So sample 1 would be the sales after, sample 2 would be the sales before. And we use a T confidence interval. We have a small samples, and we get the following results. As this confidence interval contains both positive and negative values, it is unclear what the effect of the campaign would have been. And in the last example, we have a light bulb manufacturer who wants to find a confidence interval for the standard deviation of the mean. Here are the numbers. If we find this button and mark our observations, we get a confidence interval for the standard deviation. The standard deviation for the burn time is between 108.6 and 208.6 hours. We can also square these numbers and get a confidence interval for the variance. That's all, and thank you.